Okay, let's get started. So basically what I want to cover here really quickly is a little bit of what I've been covering about casting. So if you come from a language like I do, like Java or C Sharp or C++, and you're used to generics, it can seem a little bit odd and go that we have no generics, and so some things seem a little bit, kind of unsafe. Like if we wanted to, have certain kind of operations, we'd have to cast something to some unknown type. Maybe some of us have visions of using a C void pointer and all the mayhem that ensues, but you really can't do that in Go because Go is a type-safe language, and to the extent that it can, it will um, it will keep us from doing bad things with the types that we have. But we can actually work with unknown types or things where we may want to have where we would normally use generics. We can work with unknown types in a type safe way. So just going quickly over how we define a variable in Go, we say I equals 5, and I will be implicitly typed to a 5. If we get uh, and let's so we can say I, and from the reflection package we can get the type of I. Okay, so now when we run this, we get I equals 5, and it's an integer. Okay. What would happen if we had something like a list of things? So let's have a list. So list equals, and if we're going to have a list of random things, it is going to be a slice of interfaces. So this is the interface type. And since we're going to have a slice of things, we're going to populate it with some values. We're going to 1, 3.4, and foo. Okay. So what we got here is we've got a list, and it is a slice of unknown types. That's what interface is saying. Interface is a struct type that basically says I make no guarantees about the underlying type, the underlying information stored by in a reference to that type. And I'm using reference here in the generic sense that you have a named thing. So list is saying we have a bunch of things, we don't know much about them. So one of the things we can do is if we iterated over these things, we might be interested in knowing they're doing different things based on the type. So we could have a type switch statement. Switch. So a type switch statement would allow us to perform actions based on the type of the value. So type switch. Let's just repeat this. And I'm going to do, I don't know, a room. Okay, if I run this, I see that I matched on an, oops, float. If I run this, I see that I matched on an int because I passed in one int. I see that I matched on a float 64, I passed in a float 64, but the string didn't have a matching type switch case statement. So if I change this to string, we see that our type switch matches. So that's one of the first things in our arsenal that we can look to is saying, okay, I need to know the type of the thing. Okay, I have that. But that could be a little bit verbose. You may say, let's say we've got this list, and we've got an application that's passing in lists of things, and if the first thing is a string, we do one thing. If the first thing is not a string, we do something else. So we say, let's call it head equals list 0, and we're going to cast it to a string, right? And let's do %s since we know it's going to be string. So if we do that, we're going to panic because we cannot convert an integer to a string. That's just not a legitimate conversion. Okay, so how do we deal with this? Well, we can basically do a version of cast that asks if the cast is okay. So in this case, we are saying, okay, cast it to a string, but if that cast isn't possible, set OK to false. And head will contain the string value if there's a string value at the front of the list. We can also do something if it's not castable, wasn't able to cast. And so we can do something like list 0. Okay. So now if we run this, we don't get a panic anymore, and we just say, well, I wasn't able to cast it. So if we do something here like list is equal to foo 1 3.4, and we're just overwriting list. So now if we do this, we get head equals foo because it is a string, we can cast it to a string, and we're good. Okay. All right. So what are the other things that we can kind of, I mean, this is just kind of a basic kind of functionality. So we've got the ability to match on a type in a switch statement. We've got the ability to safely cast, but we can learn a little bit more about a type. So let's do a kind of application here. So we've got int type age is a type of integer, and let's give it a stringer. And we'll say string. So this is a type of age, which is a subtype of integer. So the type age is a subtype of integer. And when we ask the system to print an age, it says blank years old, right? So we can add, say for example, age here. So make this person 25 and case age. And we're going to go ahead and print the age here. Okay, so when we run this, we see that in fact we're able to print the age we match on the type name. Great. What about down here? What happens if we put an age in here? If we put an age 25 here, we go ahead and run it. We can't, even though age has a stringer, right? We have some way of getting a string representation of age. We cannot cast an age to a string. So the concrete type of age cannot become string. So we can't cast it. But we could cast it to an age. So for example, if we said age 25, and we were to do the compact form of this, which is if a okay is equal to list 1, and we're going to cast it to an age, okay. So that's the more compact form. If we run that, yeah, we can definitely cast an age to a type of age. Okay, great. So let's leave that behind. Let's go ahead and pull this into its own function. Let's call this func holding. And we'll just grab all this stuff. Drop it there. Okay. So now let's go a little bit further and let's take a look at the reflection package. So if I say list, let's just go ahead and copy off list from down here. So let's iterate over list again. And this time we'll use the type of X. We'll use a reflection package to get the type and value of the thing that we're looking at. So we don't know what the thing is we're looking at, but we're going to get a value representation of it and the type information on it. So I can say type of %v is %v, and we can say so the value is just a value representation. Yep, there we go. Fixes that. Okay. So 1 is an integer, right? By default. And so the type of 1 of it. Oops, I got that backwards. This is going to read a little bit better now. Okay, so the type of 1 is an int, and the value is 1. The type of 3.4 is a float 64, and the value is 3.4. The type of foo is a string, and the value is that. And that's the value. Type of old, the type of 25 years old is age. Okay, so that makes sense, right? But sometimes we don't necessarily need to know the concrete type of something. We just need to know the generic kind of thing it is. Like age is in some level an integer, right? We could cast it to another integer. For that we have a thing called kind. And let's go ahead and look at this. So type of 1, whoops, kind of 1 is, and type is. Okay, so that's going to make more sense. Kind of 1 is int, and the type is int. So in this case, the kind and the type are the same. Same thing with float64. Same thing with string. But here's where it gets interesting. If we have our own type, we can say the kind of 25 years old is int, so it's based on int, right? But its specific type is main.age. Let's take a look at a couple of other examples. So let's say a type person is a struct, and it's composed of a first name, last name, and those are strings. And it has an age, which is a type of age, right? Okay. So let's add a person in here. So person, first name is Alice, and last name is Jones, and the age is 24. So Alice Jones is 24 years old. Oops. There we go. And let's go ahead and define a stringer for person too, so that they're easily printed. And we're just going to print their last name, first name, and age. So we're going to have first name, oops, forgot my, there we go. Okay, so we got a stringer on that. Those are %s's, sorry. So if we run this, we now have the kind Alice Jones, the kind is struct, and the type is main.person. So it's a kind of struct, and we can also add string in here. Actually, let's do this. Let's do func new person, first name, last name, string, age. Okay, so this returns, and let's have this return a couple of things. This returns a person and an error. Say, for example, there could be something that could cause us to error. So this is going to be person, first name, and of course the error is nil, right? Okay, and let's put in new person here. And now let's run it. So when we put in person, we get an address to a function. It is the kind is, it's a func, so it's some sort of function. But specifically, whereas the type is named main.person, the type of a function are the parameters and the it's basically the method signature, right? But the function is just an address. Now, let's go ahead and take a look and see if we can learn something about these structures and functions. So let's start with the just a type switch, and so we're just going to do switch, and this is going to be on x.type, and we're going to start. Well, actually, let's do it this. Let's do t.kind. So we're going to switch on the kind, and we're going to start with reflect dot, and we're going to start with no, let's start with a struct. So if it's a struct, we can learn some things about the struct. We can learn what the fields are for that struct. So let's go ahead and figure out what the fields are. So for j equals 0, j less than the number of fields in that type. These are struct fields, right? Now, if we call some of these vet methods on things that it doesn't make sense, like for example, num fields on an integer, a lot of the reflection package will panic. But we know we know it's safe here because we're only doing this if the kind is a struct, so it's going to have a number of fields. And we're going to go ahead and just go ahead and print f the field information. So we're going to indent by a tab and say, and so if we do that, we see that Alice the person struct, in this case the value for the type of the Alice person record is a struct of type person, right? So this data is a kind of struct. Its specific type is main.person, and it's got 3 fields. And the first name, which is of offset 0 from the base address of the person, last name, which is an offset of 16 bytes from the base address, and age, which is an offset of 32 bytes from the base address. And here, these 2 are strings, and that one's a main.age. Okay. What about functions? So here's what we can learn about functions. Now, functions don't have fields, but they have in and out parameters. So for j 0, j less than t.num in, and we're going to say t.in. There we go. And we're going to do the same thing for the outs. And let's change that to num out. And this to out. And this to out. Okay. So this function address, it's a kind of function. This address is a kind of function. And the type is a function that takes a string int and returns person error. So in is a string, in is a string, in is an int, out is a person, out is an error. Now, here's the interesting thing is we can say p is equal to, and we can, we got the value here, so we can say v, and because it is a function, we can call it and we can pass in some values. what values are we going to pass in here? That's up to us, but let's do this. Because we're going to pass in reflect values. So if you look at call takes a list of a slice of reflect values and returns a slice of values. So we can't just pass in strings and stuff. We have to wrap them in a value. But let's go ahead and create some params and an own value. And so we're going to say value of Bob Smith So we're going to pass the params, and we're going to, actually, instead of calling this P, let's call these results. So if we look at the call, of course, we pass in a list of values, and we get back a slice of values. So we know that person is equal to results and we're going to say give me an interface, and error is equal to results and give me an interface. The reason I'm getting back an interface is I don't want to work with the underlying value API, I want to work with the thing itself. So now if I do printf person, and let's indent this twice. I go ahead and person with error. So let's go ahead and run this. Whoops. That wasn't supposed to be an age, it was supposed to be an int. Fix that. Okay, let's run it. Okay. So we got back, so when we made this call, we got back the person we created and with a nil error, which is what we pretty much expected, right? So yeah, so you could see how, with some basic information, you could start, doing things like dynamically calling methods based on their signature. You could also look at navigating through structs based on the fields that they possess. So you can do quite a bit without having a generic API with both the typesafe casting that you get in Go and the reflection API. There are some serious caveats or warnings about using the reflection API, but it's worth looking into for some things. You might be able to write some library code for your application that might make some of the copy and paste boilerplate go away. It might save yourself having to generate code from some sort of code generator. So it might give you a little bit more freedom. But anyway, I just wanted us to cover this because if you are coming to Go and you're coming to Go from languages that do have generics, it can feel a little awkward, and some things where we in a type-safe manner process collections of things can seem harder in Go, but really we've got a lot of tools to in a very type-safe manner process collections, right? Okay, that's it for today, and I'm just going to post this video and get on with the rest of my day. Hope you found it useful.